Hi, hello, welcome to Homeschool. This is your class 10 mathematics NCERT or CBSE board. Today in this session, I am going to discuss with you constructions chapter. This is very simple chapter and easily we can score marks in annual examination. 1 2 marks, 1 3 marks and 1 4 marks we can expect from this chapter. So you can see a list of problems. If you are able to solve these 10 constructions perfectly, definitely you are going to score full marks in constructions. The list of questions what I have written on board are collected from the previous year question papers. Okay, let's see for 2 marks. What are all the chance of questions you may get in 2 marks? For 2 marks questions, you may expect divide a line segment in ratio. Line segment length will be given, ratio will be given. In that ratio, you need to divide the line segment. That is one question. And one more question is, they will give you circle radius. They ask to draw a tangent at end of the radius or any point on the circumference, draw a tangent to a circle, they will say. Among these two, you may get one question in 2 marks. Coming to 3 marks, they will give you circle radius, external point. From external point, draw tangents they will give you. And the distance from center of a circle or distance from the circle to external point, what they give, you should observe the statement carefully. And among these two, one may come, or radius, angle between the radius they may give, and they ask to draw the tangent at end of the radius. Or tangents inclination angle will be given, you need to draw the tangents. Among these two, one will be for 3 marks. Coming to 4 marks question, you can see here, triangle 3 sides will be given. You need to draw a similar triangle of a given ratio. Either the ratio may be in proper fraction or improper fraction. Okay, among those two, one they may ask, or they may give you any right angled triangle. Sides will be given other than hypotenuse. You need to draw the corresponding triangle to the given ratio. Among these two, one will be for 4 marks question. So these 10 problems are very important to score full marks in constructions. Okay, let's begin here. First variety of problem, that is line segment I have written. Try to understand. Divide a line segment of length 10 centimeters in the ratio 3:2. These constructions I may do on board with a rough measurement, but you please do in your fair notes with actual measurements. Okay, let's begin our first problem. Divide a line segment of length 10 centimeters. Let me draw 10 centimeters. See here, this scale 10 centimeters means only this much you are going to get. Okay, so roughly I am going to take the measurements. You please do properly. Draw a line segment of length 10 centimeters. What is line segment length? 10 centimeters. You need to divide this line segment in the ratio 3:2. Okay, so now first thing you need to do, draw a line segment. Second step, add the ratio 3/2. 3 plus 2 will be 5. Add the ratio here, numerator plus denominator. 3 plus 2 is equal to 5. Now mark this point as A and this point as B. From any one point of the line segment, draw a ray which is acute. Acute means less than 90. Draw a ray which is acute. 3 plus 2 is 5. So now on this ray, you need to draw 5 arcs. Take a skiver with the minimum measurement. So put the skiver point here. Put the skiver point here and draw an arc. Then lift the skiver from here. Draw another arc with the same measurement. Lift, draw. Lift, draw. Okay? Yes? 5 arcs completed. Now A1, A2, A3, A4, A5. Now, next step, using a scale from A5 to B, join. Join A5 to B. And the next step, observe the ratio. Numerator, what is the number you have? 3. 3 means A3. Mark a point on array A3. So here, from here I need to draw a line. Now for that sake, from A5, I just take some measurement and draw an arc. Okay? Draw an arc from A5. So, such that it should touch here and here. Now, same manner from A3, touching this ray, observe here, touching this ray, draw an arc. And now go back, measure. When you are measuring, you should disturb this. Yes. Measure. From this end point to this end point, you need to measure. And go to this arc where it is touching the ray, not A3. Arc where it is touching the ray. From there to, with the measurement, what you have measured, draw the arc. Okay. So, like this, you need to draw the arc. Now, take scale and from A3 and this intersecting point of arcs, like this, you need to join. So, where it touches the point on a line segment, that point you mark it as C. And write AB is a line segment is divided in the ratio AC is to AB in such a way. This is in the form of 3 is to 2. 3 and this is 2. Okay. So, once again, let's recollect what we have done the line segment. Draw a line segment AB of length 10 centimeters. Mark here 10 centimeters. Okay. A, B. Now from A, draw a ray which is acute. Acute means less than 90. Add the ratio, that is numerator plus denominator, 3 plus 2, 5. So on this ray, draw 5 arcs. A1, A2, A3, A4, A5. From last arc, intersecting point from here to B, join. Okay. The numerator, what number you have? 3, right? 3. From A3, so this is the point you need to remember. What you need to do? Draw a free arc and from A3 again free arc touching the ray. Go back, measure. From here measure and cut and the intersecting arc from that point and this point, extend the line, try to join the line segment. You are going to get the division of a line segment. Therefore, line segment AB is divided in the ratio AC is to CB in 3 is to 2 ratio. Similarly, you try to do the second problem. Divide a line segment of length 8 centimeters. Divide a line segment of length 8 centimeters. What is the line segment length? 8 centimeters you take. And the ratio 5 is to 3. 5 is to 3. Add the ratio. 5 plus 3 will be 8. Draw a ray which is acute. How many arcs you are going to draw? 8 arcs you are going to draw. From A8, join to the B. And numerator, what do you have? 5. Means A5 onwards, you need to draw in this manner. Arc, A5 arc, measure, cut, join. Okay. This is a word you need to remember. Arc, arc, measure, cut, join. Okay, you are going to get the division of a line segment in the ratio 5 is to 3. You are going to do second problem. And to score full marks, you need to write here, given line segment length so and so 10 centimeters and line segment is to be divided in the ratio 3 is to 2. And then again, therefore line segment AB is divided in the ratio AC is to CB. And these all statements, if you end your problem, you are going to get full marks. Either dividing a line segment or this variety they may ask you. So look here, 7th problem. Draw a circle of radius 4 centimeters and draw a tangent at a circumference of a circle. At any one point of circumference of a circle, draw the tangent. So let's understand this problem. Let's draw a circle 4 centimeters radius. Okay. At any one point on the circumference, any one point. So let me take this point. Draw a tangent by considering any one point on a circumference of a circle. So with this point, I am going to draw a tangent. Have to draw a tangent, do you remember? I am just going to show you roughly now. First thing, if you need to draw a tangent for a circle of radius 4 centimeters, what we need to do? First draw the radius. Then with the same measurement, draw semicircle. And again lift the skiver, put it here above one arc, on semicircle one arc, and from here cut the arc, from that intersecting arc join. This is your tangent. So again I repeat, with this as a center, draw a circle and do the radius. The same measurement, lift the skiver and put your point here too. Do semicircle. Again lift the skiver, put your point here. I just number the point how we are lifting your skiver. Put here and draw circle, put here and draw semicircle, and put here and draw an arc above and on the semicircle. And lift your skiver and put your point on 4. Put your point here and cut the arc. You are going to get the tangent. Okay. Mark this as P. AP is a required tangent for a circle 4 centimeters. This is a rough figure. Let's go with the actual measurement. So let me take this as a 4 centimeters radius. Draw a circle. Okay, with 4 centimeters as a radius, I have drawn a circle. And now using a scale. Now using a scale, join this. Okay, we got a radius. This is a center O and mark this point as a P. Observe there carefully. First, put the point at center and we have drawn a circle. And now lift the skiver, put the point here and do semicircle. Okay, now lift the skiver and put the point here. Third step, above one arc, on the semicircle one arc. And now where the arc touches the semicircle, from there to cut the arc. Take a scale and try to join now. This is your tangent. Mark this point as A. You can end your tangent here. AP is a required tangent and mark here 4 centimeters radius. AP is a required tangent. Make sure to write the statements properly. Given circle radius 4 centimeters and P is a point on circumference of a circle. A tangent AP is a required tangent for this circle. Okay, so similarly, you can take any other circle of your own measurement, 5 centimeters, draw a tangent or draw 2 tangents at the end of your radius, or draw a diameter. They may ask at the ends of the diameter, draw 2 tangents. They will ask. Don't worry, how you have done for single tangent. Same manner, extend this radius, it becomes the diameter. So draw another tangent at this point. Semicircle, how you have done? Do semicircle again this side. And same manner, on semicircle above one arc. And from here, cut the arc. So like this, you are going to get one more tangent. Okay, these are all the 2 tangents drawn from the ends of the diameter. Like this, any type of question you will be able to answer. These questions they may ask you for 2 marks. Let's see the next variety of problems. You can see tangent, circle radius and point you can observe. Look here, this is circle radius and this is the external point distance you can see. You need to draw tangents from external point. Draw a pair of tangents from an external point to a circle of radius 3.5 centimeters. Tangents we need to draw from an external point to a circle. Circle radius is how much? 3.5 centimeters. Given radius of a circle. Given radius of circle is equal to 3.5 centimeters. And what is this? External point is 8 centimeters away from the center of the circle. This point is very important. Let me read the question again. Draw a pair of tangents from an external point to a circle of having radius 3.5 centimeters are at a distance of 8 centimeters to the center. 8 centimeters is what? External point distance. So observe here, rough figure first. Circle radius is 3.5 centimeters. This is the circle and circle radius is 3.5 centimeters. I am talking about external point. How much distance it is? 8 centimeters. 8 centimeters from center there. Center of a circle from here to somewhere here external point there. From here to here 8 means how much distance should be there here? What is the length of this line? Then what will be this length here, children? Radius is 3.5 and from here to here it is 8 centimeters. In 8 you subtract 3.5, that will be 4.5 centimeters. So look here, 4.5 plus 3.5 will be 8 centimeters. So from here to here 4.5. Observe here, that means 3.5 plus 4.5 centimeter will be 8 centimeters. So external point is 8 centimeters away from the center of the circle. From this point you need to draw the pair of tangents. That is your problem. Okay, let's do the construction. How do we do first construction? Draw a line segment. What is a line segment length? Look here, 3.5 plus 4.5 will be 8 centimeters. Let me draw a line segment. This is 8 centimeters line segment. This is external point you can imagine and you can mark this as P, external point P. And you can mark this as the center of a circle O. Now with O as the center, what is the circle radius? 3.5 centimeters. 3.5 centimeters. Draw a circle. This is 3.5 centimeters. I have drawn a circle from center O. Now we need to draw the tangents from this point, right? How we need to draw? First step, line segment. Second step, from one end point of a line segment, draw a circle of radius 3.5 centimeters. See here, from any one point of the line segment. See here, from one end point, you just measure more than half and draw more than half above one arc and below one arc. Same measurement from this point P, cut the arc and cut the arc. Okay, why we are doing this? In order to get the bisector. Join these two. Okay, now the bisector, what does it do? It divides the line segment into half. So with this as a center, with this as a center, draw semicircle. Two tangents now. So just complete the circle. If only one tangent, semicircle is enough. Two tangents means full circle we need. If you want, you can do this with a dotted line also, you can do. Now at this point, you need to remember one statement. What is that? New circle touching the old circle. This is a new circle, right? Old circle is this, where it is touching from this here, from this point and this point. New circle where it touches the old circle. From that point to try to join. This is one tangent. And again here where it touches from there to this point. So the scale is not enough for me. Just observe here. New circle where it is touching old circle, from that point to external point join. Here also same manner, from here to here join and mark this as A, B. Therefore, PA and PB, and PB are the required tangents. You need to end your problem by saying PA and PB are the required tangents or a required pair of tangents from external point to a circle of having radius 3.5 centimeters. Okay, similarly, you need to do another problem. What is that problem? Draw a pair of tangents to a circle of radius 4 centimeters. Okay, and external point 5 centimeters away from the circle. Observe the word what I am saying. 5 centimeters away from the circle. That means you can see here circle radius is 4 centimeters. External point is here. 5 centimeters, external point is 5 centimeters away from the circle. Means what is this length? 5 centimeters. 4 plus 5 total line segment length is 9 centimeters. Observe the point carefully. External point is away from the center or away from the circle. You should observe carefully. Now this is away from the circle. So from here 5 centimeters. Total line segment length is 9 centimeters. Now same manner you need to do the construction. What is the line segment length? 9 centimeters. 9 centimeters, draw a line segment and with one endpoint as a center, draw a circle of radius 4 centimeters. Okay. Then again more than half arc above one arc, below one arc, and from here cut the arc. You are going to get a perpendicular bisector. Then bisector where it is touching the line segment. From there to measure and draw the circle. New circle where it touches the old circle. From that point to join external point. Those are only the pair of tangents. Okay. They may ask you measure the tangents. Measure means with scale you can measure the length of the tangents. Coming to 3 marks, one more variety of problems you can see. Fifth one, draw a pair of tangents to a circle of radius 5 centimeters and they have given a point. You need to observe the point. Radius angle is 60 degree. You need to draw a pair of tangents to a circle. So first thing, have to do this problem. I just go on doing with free hand, roughly I am going to do. You please do properly with your construction tools. See this one, 5 centimeters, draw a circle. Just 5 centimeters, draw a circle and let me do one radius. Okay, this is center O and this is point A. First thing what you have done a circle with radius 5 centimeters and join to one point on circumference and say it is a radius. They have given radius angle is 60 degree. Radius angle 60. How to do this one? Draw an arc and again first arc is 60 degree. Right? With the skiver you can make the angle or with protractor also you can do this angle. Now this angle is how much? 60 degree. So try to join and touch the circumference. And this becomes the radius. The angle between these two radius is how much? 60 degree. I need to draw tangents to this circle and the radius angle is 60 degree. When we know radius angle, we no need of bothering about tangents angle. Okay, directly we can draw the tangents. How you can draw, children? You have seen 4 steps. Same manner, semicircle. I just do roughly, children. You just do neatly semicircle and lift the skyver and put here on semicircle and on above one arc, and again from here cut the arc. Try to join, and at only one point it touches. This is your tangent. Same manner, you can do for this radius another tangent. Either you may do semicircle this side, or you may do semicircle this side also, no problem. So look here, again like this you may get one tangent. Okay, so this is the point, only at one point it touches, children. That is called as a tangent. So mark this point as A and this is P. PA and PB are the required tangents. PA and PB are the required tangents. If you measure with protractor, this angle will be 120 degree. Okay, so same manner, another problem. Look here carefully. Circle radius is 4 centimeters. What you are going to do? You do a circle of radius 4 centimeters. And now tangent's angle is 70. See here, this angle is given for you. If this angle is 70, what you need to do? This angle you should find out first. If that is 70, then what will be the central angle? 180 minus 70, 110 degrees, the central angle. Now, in that manner, do 110 degrees first here. Using a protractor, you can make 110 degree and draw the radius. Then same manner, with this radius one tangent and with this radius another tangent, and you are going to get two tangents. And this tangents, they will intersect at one point. If you check with protractor, this angle will be 70 degree. So same manner, write the letters. Therefore, PA and PB are the required tangents for the circle. You need to end the statement compulsory. Okay, you need to do this construction with your construction tools. Next, let's discuss about 4 marks variety of problems. You can see here 8, 9, 10. These 3 varieties may come for 4 marks. 8th problem. Draw a similar triangle. Given sides of a triangle are 5 centimeters, 6 centimeters and 7 centimeters. Draw a corresponding triangle in the ratio 7:5. So observe these, children, carefully, and let me do one rough figure. You do original figure. Draw a base of a triangle. So base length, what you need to take? What is this line segment? Which measurement you are going to take here? See here, which is greater? 7 is greater. So draw a line segment of length 7 centimeters and mark this as AB. And other measurement 5 centimeters, 6 centimeters. Now what you are going to do? Take a skyver, 5 centimeters, draw an arc. Okay. And now from another point, 6 centimeters, cut the arc. Then try to join. This is 5 centimeters and this is 6 centimeters. Draw a triangle with the given measurements. 7 centimeter, 5 centimeter, 6 centimeters you have drawn. Now, draw a similar triangle with the corresponding sides in the ratio 7:5 is your problem. So, how to do this one? First, by observing that ratio, you can say your new triangle is outside or inside. How? Let's see. Okay, look here. Is this proper or improper fraction? Numerator is greater than the denominator. If numerator is greater than the denominator, it is improper fraction. Okay, I'd like to say with one example. Just try to remember with this example. By seeing the ratio, you can say whether your new corresponding triangle will be outside this triangle or inside the triangle. Okay, let's take a tiny example and just relate to this problem. What is that example? Okay, let me say, yeah, school timing will be at 9:30. So a child started at 9:20 at home with a bicycle and within 10 minutes reached school. Means within school time they have reached the school. So if they reach school, where they are going to sit? Properly inside the classroom. Means in time they came to school, no? They are going to sit inside the classroom. So what is the point you need to understand here? If the fraction is proper. See here, suppose if I take 2 by 3. 2 by 3 is which type of a fraction it is? Proper fraction. Proper fraction. If properly you come to school, where you are going to sit? Inside. Okay, inside. You just need to remember here, interior of the triangle or inside the triangle. You can remember, anything is okay. So what is the half example I have said for you? A child reached the school within the school time. Okay, then they are going to sit inside the classroom. If they come properly to school, they are going to sit inside the classroom. Proper inside. Okay, suppose school starts at 9:30. If they start at home at 9:20, they can reach school. But what the child do? They may go to for any stationery shop, it might be, or any Xerox shop, or they may wait for any friends. So what they do there? They are doing late. Properly, that child is not coming to school. They are going to stationery shop, Xerox shop, and waiting for friends. So they are coming improperly to school. Improper in the sense there, what you need to understand, coming late to school. Okay, proper means directly coming to school. Improper means wandering other shops and all. And if they come to school, so does the time will be sufficient? No, they will be late to school. Okay, if they come late to school, what does the teacher says? Stand outside or sit outside. Means they are going to be outside the classroom. They are going to stand outside the classroom. What is the thing we need to understand here? If your fraction is improper, if your fraction is improper, where you are going to sit? Outside. Okay, just a tiny example. If your fraction is proper, inside. Improper, outside. Properly coming to school, inside the classroom you sit. Improperly you come to school, you will be late. Then you will be outside the classroom. So first observe the ratio. See here, 7 by 5. 7 by 5, is it proper or improper? Improper. So where will be the new triangle? It will be outside the triangle. Okay, see another ratio here. 2 by 3. 2 by 3 is proper or improper? Proper. Means the corresponding new triangle will be inside the triangle. This is a tiny example to just have a fun to understand what you have done the construction is right or wrong. Or by seeing the ratio itself, you can guess where my new triangle is going to get. Okay. Now your ratio is improper. You can say by using that example, ma'am, the triangle will be outside. Outside. How can I draw the corresponding triangle? Here we are not going to add the ratio. Which is greater, 7 or 5? 7 is greater. Okay, check the number which is greater, either numerator or denominator, no problem. 7 is greater, right? Draw a ray which is acute. How many arcs I need to do? 7 arcs. 1, 2, 3, 4, 5, 6, 7. And what the letter continued? A, no? A1, A2, A3, A4, A5, A6, A7. Okay, observe the ratio. Whereas in line segment, we are going to add the ratio. But in this similar triangle, we need to see which is a greater number, and that many arcs we need to do. Now, what we need to do? What is the denominator? Denominator is 5. At 5, join point B. At 5, join point B. Now, your ratio, according to your ratio, you can say outside the triangle. So, you need to extend this line. You need to extend the line carefully. So, your new triangle will be outside, right? Now, this point is very important. Now, from here, what we need to do? Free arc. Draw a free arc. Okay? Again, lift your skiver and put at A7. And draw again free arc. No problem. Touching this arc, you can draw. Now go back and measure these two distance. You can disturb the skiver. Yes, measure means this much there. Then again, where it is touching the ray, from that point to check and cut the arc. Take a scale and try to join. Okay? And now same manner. From here, observe from B, again do the arc, and again from this point, do the arc, go back, measure and cut. Okay. Now, when you are joining these 2 points, try to extend, you are going to get another point. So, observe here, C extension, C dash. B extension, you can mark B dash. So, ABC is the original triangle and AB dash C dash is the corresponding triangle of having sides 7:5. Let us have a recap again. With the given measurements, draw a triangle and at one end point draw a ray which is acute and observe the ratio which is a greater number, that many arcs you do. Okay, so after drawing, see the denominator, what you have? 5. At A5, join another endpoint of the triangle and try to extend, okay, and do the arc, measure, cut, join, arc, measure, cut, join, okay. Therefore, A, B dash, C dash is a required triangle or is a similar triangle for ABC. Is a similar triangle for ABC. Okay, write neatly with all the steps carefully. And same manner, see the 9th problem. 4 centimeter, 5 centimeter, 6 centimeter. Draw a triangle and the ratio is 2:3. So look here, I just go with a rough figure. Let me go 6 centimeter, 4 centimeter, 5 centimeters. I have drawn a triangle. What's your next step? Draw a ray which is acute. Okay, and your ratio is 2/3. Observe which is greater. 3 is greater. So you can go for big arcs. 1, 2, 3. And mark this as A, B, C or P, Q, R, any letter you can take. A1, A2, A3. Observe the denominator. From denominator to another endpoint, you need to join. 3. 3 is denominator, from A3 to join. Okay. Now what is your numerator? 2. See here, this is the point where you need to do. Again, one statement you need to remember. What is that? Free arc, go back, measure, cut, join. Okay, same manner again. Arc, measure, cut, join. C dash and this is B dash. A, B dash, C dash is the required triangle for a corresponding ratio 2:3. Okay, so this is the way we need to do, children. Most of the people will do wrong, where they are going to try to measure from the point, they may measure and they may cut the arc. Don't do that. From the arc where it is touching the ray, From there to you need to measure. And by seeing figure, you will be able to say whether it is right or wrong. How? See here, these two lines will be parallel. If these two lines are parallel, you can say your figure is right. Observe here, these two are parallel, these two are parallel. If they are parallel, your construction is correct. For 4 marks problem, you need to do the construction steps also carefully. Write the step, how we are doing the construction. Same manner, you can write it in the form of construction steps. Coming to last problem. Last problem also same variety. Draw a right angled triangle. Draw a right angled triangle. The sides other than hypotenuse are 5 cm, 6 cm given. And ratio 2:3 given. How we need to do this one? Right angle triangle I need to draw first. Okay, right angle triangle, sides they have given other than hypotenuse. Other than hypotenuse, 2 sides are given. Ratio 2:3. We need to draw the right triangle first. Other than right angle, other 2 sides length given. Ratio 2:3 given. What we need in the problem, I have written with a shortcut. First, 5 and 6, which is greater? 6 is greater, right? So, draw a line segment of length 6 centimeters and mark this AB. Right triangle means one angle is 90 degree. Suppose if I take this as a right angle, this side and this side I know. If I take this as a right angle, this side and this side I know. Right? So I take here as a right angle, this point as a right angle, 90 degrees. We'll do 90 children. Arc. This will be 60, this will be 120. And in between these two arcs, you can get a right angle. Yes, I think everybody of you know how to do 90 degree angle. If you don't know, you can use with protractor also, no problem. Right? 90 degree, do a perpendicular and put this symbol. Okay, and make this and say this is right angle. Now, what is this side length? 5 centimeters. Measure 5 centimeters and cut the arc. Now, join. Okay. Now, what is this length? 5 centimeters. In a right triangle, other than the hypotenuse, sides are 5 and 6 given. So, we have done 6 centimeter, 5 centimeters, right triangle we have done. Now, we need to draw a similar triangle with the corresponding ratio 2:3 or with the sides having corresponding ratio 2:3. So, observe that ratio 2:3. Is it proper or improper? Proper. Proper means where will be a new triangle? Inside. Okay, proper inside the classroom, right? So, proper inside the original triangle you are going to get. From A, draw a ray which is acute. Observe the ratio which is greater. Numerator or denominator? Denominator is greater. With what? 3. 3 arcs. 1, 2, 3. A1, A2, A3. So, from A3, try to join this. Okay. And numerator what you have? 2. So, from 2. Same statement, do you remember? Arc, measure, cut, join. Same manner, arc, measure, cut, join. So, take scale properly and try to join. So, here it is little, it's not parallel, but the actual figure if you see, you are going to get these two will be parallel and these two will be parallel. And mark this point as B dash and this point as this is C and this is C dash. Therefore, triangle A, B dash, C dash is a required new triangle for the triangle ABC. Okay. In this way, we need to do any type of similar triangle if they ask. Try to think carefully. Draw first original triangle. Observe the ratio. See which is greater. That many arcs you need to do. And what is the denominator? That denominator point you need to join the end point of a triangle. Construction is very easy, children. Definitely you are going to get full marks if you're able to write given data, and if you're able to observe the figure, whether you have done is right or wrong, and you need to write all the measurements, everything perfectly, you are going to get full marks in constructions. Okay, all the best. With this, we are going to end the session today. In our next session, we are going to meet with another new chapter. Until that, keep watching. Thank you all.